Question 16. So we're gonna need to once again use structural formula, write the reaction, and then write the name for everything. Well, one of them's water, so we get one going for us. It's probably a good idea to start with the ester. Let's see whether there's a better way to do this. Alright, I'm gonna do it here. I don't think there's a better way. You should have concentrated sulfuric acid as the catalyst. So get into the habit of writing it every time you make an ester. This is a C double bond O O. Okay, so the C double bond O O, you have a C double bond O, and then you have another O. So I'm going to write the ester out first. C double bond O, and then O. And on the left side of the carbon, you have a hydrogen. And then on this side, you have one carbon, another carbon, and another carbon. If you get this step wrong, it's very hard to get the reactants correctly. Okay. A trick, not really a trick, a choice really. You can try to name this, and if you name it correctly, then obviously you, well, most likely will get the correct reactants. So the thing that people tend to forget is which part belongs to the alcohol and which part belongs to the carboxylic acid. So you can cut it out in the middle. Now if you do this part, the part that has the single bonded oxygen, that's the alcohol part. So I'm just going to make a note here. So you don't really need this bit in red in your working out. But this is the alcohol, and the part that has the carbon double bonded to an oxygen, that's your carboxylic acid part. So if I need to name this thing, I still need to name the alcohol first. So it will be called propyl. And there's only one carbon in the acid, so methanoate, which is always a good one to draw. So the two reactants, if you name the ester correctly, it shouldn't be too hard to work out. One of them has to be propanol, and the other one has to be methanoic acid. Okay, so let's draw them out. I'm going to draw it vertically just because I am a little bit short for room. So, looks like that. Kind of reminds me of glycerol. You'll learn about it later. Okay, this one sometimes trick people because it has only one carbon, but it looks like this. And do not forget to write using structural formula and name water, which is actually the byproduct. It is a condensation reaction. It needs to have water in it. All right, part B. So we're going to start with the same procedure. This is a massive ester. You should have concentrated H2SO4 as a catalyst. Let's start with the C double bond OO. I'm going to try to squeeze the whole thing in. I'm not sure how successful I will be. We'll see. Okay, left side. 1, 2, 3. Oh, that's not too bad. 1, 2, 3. Hopefully in your piece of paper you have more room to work than this. So you don't have to have the product underneath the arrow. That looks kind of odd. Okay, right side. 1, 2, 3 again. And all you do is filling in the hydrogen. Right. Now the carbon, that's this part with the single bond oxygen, this is your alcohol. So once again, it is very similar to the previous example. On the alcohol side, you start with a propyl, and then on this side, this is your acid side, it has 4 carbon, so butanoate, which means that your reactant must be propanol and butanoic acid. Okay, 1, 2, 3 OH, and then we do the same thing. Try not to rush it, even though I've been complaining about having to fill in the hydrogen. Try to make it clear as much as you can, because if I can't read it, that's bad. This is a terrible working out, by the way, but I don't have enough room in my slide. You cannot get away with this in a sack. Be careful, make sure you actually have only 4 carbon in your main chain for butanoic acid, so you don't add an extra carbon unnecessarily. And do not forget the final product, which is H2O, and name it. And I think that's it for 60.